Thank you very much, Christopher, for that introduction. My name is Paul Taubman with 9.Connects, and I'll put my mug up here so you can see what we look like here behind the screen. Also joining me here today is my colleague Tom Cassidy. So both of us have degrees in electrical engineering one way or another. However, both of us have spent quite a bit of time on the mechanical side as well. So what you're going to see here today is really going to be presented just as much from the mechanical side as it is going to be presented from the electrical side here today. So just wanted to just give a little brief introduction to who we are and where we're at over here. And you are in the right place if you're here for our webinar on One Step Beyond. So why don't we get to it here? Just one very quick housekeeping note. If you have any questions, feel free to type those in. There is a questions panel in the overall panel that you get with your GoToWebinar. At any time, if you want to write a question, feel free to do so. We'll definitely take a look at that. When say we, it'll be myself and Tom will look at that towards the end. But Christopher can probably answer a couple of other questions as well. So if you want to type that in at any time, feel free to do so. What are our objectives here for today? Number one, let's talk about the limitation of step files. I'm pretty sure that at some point or another you've probably looked at them or you've created them, and you may even be using them for collaboration between the electrical and the mechanical side of things. So we'll take a look at that. We also want to talk about the path between SolidWorks Pcb and SolidWorks Cad. So a couple of things here that we want to make note of. First and foremost, we know a lot of people who are using SolidWorks always just call it SolidWorks because that's the flagship program. We are going to differentiate between SolidWorks Pcb and SolidWorks Cad because first and foremost, SolidWorks Pcb is a separate tool. It is not something that you add into SolidWorks Cad. Secondly, just for everybody's knowledge here, we are running SolidWorks Pcb and SolidWorks Cad on two separate computers in two separate cities. And we'll talk a little bit more about that as we go here, just to show you the ability to collaborate despite geographical differences. An ultra quick understanding of Ecad library structures. And the reason we want to do this is because it'll show you why the SolidWorks Pcb to SolidWorks Cad connection seems a little bit convoluted because we can't necessarily just push files from SolidWorks Pcb into SolidWorks Cad and vice versa. We have to kind of explain why things actually start on the Ecad side of things. We'll give an example of how you initiate an Ecad initiated design to MCAD. So we'll show you where an electrical design is being pushed into the MCAD side, and then vice versa. We'll show if someone has actually started the MCAD side, how they can push something into the Ecad tool. And of course, we'll have some time for questions and answers thereafter. So let's get on with it over here. Okay. So these step files have been around probably for about a decade now. That's really when Ecad realized that, hey, we have a way of communicating with the MCAD world and vice versa. And so we started passing back and forth step files to each other. And it's really great because it kind of bridges this massive chasm that's always existed between the MCAD folks and the MCAD folks there. So we're using this as a bridge and allows us for collaboration. But if you've ever done this process of collaboration with step files, this is what it looks like over here. It's very, very administrative in nature. So somebody will create a step file, whether it comes from the Ecad side or the MCAD side. They export this. You got to write an email to communicate that, and then somebody's got to either download it or they've got to put it up to an FTP site. And you go through this whole process back and forth of basically communicating with each other, telling where this file is, importing, exporting, making sure you can get to that file. And you go through this several iterations. And so it's very administratively intensive. And that's one of the biggest disadvantages of it. So we deal with the importing, exporting hassles of it. And in SolidWorks Cad, what you notice, if you've done this before, that the PCB and its components really come in as a bunch of individual assemblies. So there's a lot of work that needs to be done. So graphically, it looks great, but intelligently and its usefulness is really, really limited. And in SolidWorks Pcb, the component comes in as just one big glob of a component. It's only really a visual representation, and we can't do much with it. And quite frankly, even if we could do something with it, there's just no intelligence behind any of this, whether you're looking at it from the MCAD side or the PCAD side. It's really for aesthetic purposes only. So I'm going to jump out of this PowerPoint for just a moment so we can demonstrate this. So what I've got here on my screen is I've got both my picture up over here. So I'm using SolidWorks Pcb, Okay, so you can see that here on the left side. And on the right side, you can also see Tom Cassidy's screen. So I'm actually here in San Diego, California, and Tom is actually broadcasting from Houston, Texas. All right, so we've got both these screens up over here. So we'll be pushing, showing the screens in full as we're going along over here. So Tom, why don't you show what happens when you bring in something, a step file into Solidworks Cad?
Okay, hello everyone. As Paul was mentioning, this is a step file that we exported from the PCB program, and as you can see, it looks pretty nice. There's all the components we have on the board, pretty good detail. But if you see over here on the left, each of the devices is really just a step file itself, and there's really not much you can do with it within SolidWorks. You can't open it. If you wanted to mess with it, you'd have to convert it and go through all that mess. So like I say, this is really good if you're just trying to see if it fits into an enclosure or generate a nice picture with Visualize. But for the most part, from a usefulness point of view, it's pretty limited.
Okay, and so you can see the limitations there on the Ecad side of things, pardon me, the MCAD side of things in SolidWorks CAD. So what I'm going to do over here is I'm going to bring up SolidWorks PCB and show the issues that we have on our side of it over here. So I'm going to extend out my screen here. All right. What I'm going to do is I'm going to bring open a document here. So here's a document that's in its 3D mode. And by the way, in SolidWorks PCB, we tend to work in the 2D, but we can render things in the 3D mode over here. So what I'm going to do is I'm going to bring in a step file, very similar, actually it's the exact same one that Tom just brought in, and show you kind of its limitations as well. As a matter of fact, we really don't even import it in. It's actually treated as an object over here. And not to get too bogged down in the minutia of things here, but I'm going to bring it in as an object because that's the only way I can actually bring it in here. So if you give me a moment here, we'll bring that in. So here's our rangefinder.step file. By the way, everything that you're seeing over here is a real project. We have manufactured this. So it's not just some concept drawing that we're doing here. What you see on the MCAD side and on the Ecad side, we have manufactured. So I'm going to bring this open right now, and I'm going to press OK. And I'm going to allow it to bring it in. And it's kind of a large file, so it's going to take a moment here to bring it in. Okay, so here it is. And so once it's been brought in over here, you'll notice that there's nothing here on the 2D. It's just kind of coming in as just as a box with some hash lines in it. So if I go into the 3D mode over here, I'm going to hit the 3 key. There it is. So there's my step. Okay, and that's all I can do with it. I can't move any of the components around. I can't route on this thing. I can't change the board size. I can't change the mounting holes. That's all I've got. So if this was an enclosure and I had my printed circuit board set up over here, this could be useful because I could do some fitment checks. But from an electronic point of view, trying to get any information off of this, it's really just for visual, and I can't get any intelligent information off of it. I would have to draw it or get it from other sources. So that's really the limitation that we have with the step files here. So, all right, let's do this over here. I am going to just park this back here, and let's jump back over here to our PowerPoint slides. Okay. So what's the solution? The solution is that, yes, we can pass 3D information back and forth with each other, but we have to have something that assists us with it because the way we do things in Ecad and the way we do things in MCAD are very, very different from each other. So what SolidWorks has come up with is really 3 different products. So there's obviously your traditional SolidWorks Cad, as we've been calling it here in this presentation. We also have SolidWorks Pcb. So this is the new product, and this is the one that we support here at 9.connects. And this is a server that comes with SolidWorks Pcb that allows this interface to happen with each other. And as I mentioned earlier, I am in San Diego, so I'm running SolidWorks Pcb from my computer in San Diego. Tom's running his in Houston, Texas, and we actually have a server that's sitting in Austin it's going to allow us to communicate back and forth with each other. So the idea is kind of a push and pull. We push information from one side into the other. So if I'm done with something here on the Ecad side and I want to get it to the MCAD side, I push that into the services, and then the MCAD side will pull that in. They can make changes to it. They push it in. I can pull it in, and we can go back and forth with each other. Now, the Ecad tool, SolidWorks Pcb, does own the project, and the reason we have to do it is library issues, which I'll explain in a moment. So when something gets initiated, the Ecad really does have to own the project and initiate the project. However, MCAD can certainly generate and modify the board. It can move components. It can add mounting holes. It can change the size of the mounting holes. It can move around delete mounting holes. So it can do a lot of things to it, but it really does Ecad does have to own the project. So why is that? Well, it has to do with library structure. In the MCAD world, it is very elegant the way things work. If you work on a part, it also can become something that belongs to a library. So you're really doing two things at once. You're building a part specific for a project, but you're also building it so that someone can use this again in the future. And so you really do kill two birds with one stone. Afterwards, you take those parts and you put them into assembly. So you've got something that goes from the bottom up. It's a really nice flow. We don't have that luxury on the Ecad side. And the reason we don't have it is because we need to have two steps when we put together a printed circuit board, and that requires two libraries. So when we do a schematic capture, this is a dimensionless concept. We just have to show how things are going to connect with each other. And there can be literally thousands of lines of connectivity that has to be done, especially if you're using like a 1000-pin FPGA or microprocessor. You've got to show that concept as how things get connected together. That creates something called a net list, which is really, really important on the PCB layout side here. But in order to do any drawing here on the schematic capture, we have to represent the components in what's called a symbol library. So here's an example of a resistor that we would have in our symbol library. So here's a resistor over here. In fact, it's a potentiometer, so it has 3 pins rather than 2. But the part itself doesn't look like this in real life. That's what they use here as a symbol. It's a little squiggle line. And later on, we're going to tell this information or give this information once we're done with it and push it to the PCB layout side. This is where we start drawing the physical aspects of the PCB. And you can see over here that we now require something called a footprint library. So here's the footprint equivalent to what this symbol looks like here. And what we do with that is in the footprint library, these footprints are where we want to basically connect the component onto the board. So ultimately we need, let's just call them landing pads, and that's why they call them landings. And sometimes they call them pads. But we never call them landing pads. But the fact of the matter is they're there so that when the component is placed onto the board, they can solder those on. And that's what we need to have available in this particular library. But in addition to that, Solidworks Pcb allows for a 3-dimensional component to be placed on there too. And that's where things kind of begin, because in the PCB layout, if we have a footprint library with the 3D component on there, we can push that information to the MCAD side, and in turn, MCAD side can move things around, push it over, and we can kind of now talk in this 3D language. So that's what I want to show you here on the PowerPoint slides here. But what I want to do now is we want to demonstrate this ability to push and pull stuff in pretty much near real time. So I'm going to jump back over here, and I'm going to extend out my screen for just a moment. And let me go to a project that is complete. So here's a project that we put together. This, again, is the range finder. So there's 2 pages of this range finder. Here are your symbolic, here's the schematic with the symbols in it. Okay, and that's all it has. It just shows us the part and the pins and how they're going to connect up to the other parts. Okay, this over here is the board itself. So let's bring that in here. Okay, so this is the physical connectivity. Now we don't have any of the routing done. And the reason we don't have the routing done is that normally in a very good collaboration environment, what would happen is that you want to push this information where the components are going to be to the MCAD side so they can make sure it can fit in whatever enclosure that they may be designing here. And so all these things can be moved. The board shape can be changed, the mounting holes can be moved, and the components can be moved around as well. And that's what we want to do, because if we route and then we've got to move something, even if it is an 1/8 of an inch, if we have to move it and it's already been routed, in some cases that could take us a week or two, especially if it's got 1,000 pins associated with it, because the rubber banding is pretty limited. And if you got something that's got 8 layers and 1,000 pins on it, you can't just simply move it or nudge it over a little bit. There's a lot of work that has to be done. They effectively have to tear up all the routing, move it over, and then reroute it. So we don't send the stuff back and forth in a routed state. The routing is done after everybody is happy with the component placement. So that's what I've got over here. So what I'm going to do is I'm going to initiate the process of pushing this into the PCB services, which again is sitting in Austin, Texas on our server. And then once I'm done with that, I'm going to show Tom's screen so he can watch him pull it in. Okay. So I'm going to do this here. I'm going to click on our tab here. This is our collaboration tab. Okay. And I'm going to discard this one. You don't have to worry about this one here. Okay, and let's do this. I'm going to push this over. And by the way, it does keep track of the comments. So when we push something over, there is going to be something there saying, hey, check this out. There's been a change made to this. So that's what's going to happen here. So I am going to push this, and I'm going to be able to comment. I'm going to say, hey, the initial review for MCAD. And it can be any comment that you want, but something that would be useful for the person on the other end to understand. So I'm going to do that here. Actually, I'm going to split the screen so you can kind of see what happens. Okay. So here's the initial review, and I'll post it. Okay. And so you can see that it's going to start pushing this. So again, it's going to take all the information that it has over here about all of these different step files. The board information is pushing it into this, into the PCB services. Okay. So it's now been completed here. And on Tom's side here, okay, so on Tom's computer, so Tom needs to initiate the pull-in initially here, or pull it in from the services.
Okay, do you want to maximize my screen?
Yeah, certainly. Let me do that.
Okay, so as Paul mentioned, the Ecad pretty much owns the project. So he starts, he says, okay, I've pushed something, he lets me know. So I go over to my project, I've opened up a new assembly, but it's basically blank. You could also, if you wanted to, just start off with a new board assembly. But what I'm going to do is over here, it says pull board from PCB services. And I've already connected to the service using the logging in, so I'm not going to do that. So I'll just click pull board from services. It'll check with our server and give me a list of the projects I'm allowed to access. And so I'll use today's.
Yep, no, use the top one, rangefinder.
The rangefinder project here.
Yep.
So I'll say okay, and you'll see it'll go ahead and start talking to the server. It's going to ask me where I want to store files locally. Since it's SolidWorks, it's going to need to put stuff on my own computer as well to keep track of the model. So I'll just give it a local directory and sit back and wait. It's talking to our server in Austin and basically importing the information from Ecad, converting it to what SolidWorks MCAD needs. And as it thinks it through, it'll eventually start showing me how it's going to start building the project locally.
The initial pull from the services, since this is a brand new project on the MCAD side, does take a little bit of time. Once it's been pulled in and you make updates, it moves a little bit faster simply because now that information has been saved on Tom's computer. So.
Okay, so now you can see this is the project, and I see my initial review for MCAD message from Paul. And just let me point out real quick that as a differentiator between the SolidWorks, you can see this is a real SolidWorks project. This isn't a step file. So all the parts that are on here have their own parts, SolidWorks parts. They're not step. And so consequently, I can open them. I can do whatever I want to within SolidWorks. Now, part of the collaboration is basically me saying, okay, I don't like the way this is. I need to change it. So what I'm going to do is take this chip here, which I see is U1. I'm going to say I prefer to have it up closer to this switch over here. So basically I say, okay, I think it'll work better there. So I'm going to put it there. And I'm going to say to Paul, I'm going to push this back to the server. As I push, I get the same kind of a dialog box that Paul got. I'm going to say, send him a message saying, I'd like to move U1 closer to the dip switch. And I'm going to go ahead and post this. And if you can see on the split screen, after I post it, one of the nice things about this is it occurs pretty much in real time. As soon as I say something to Paul, he'll see it right away on his system. And there we go.
You can see, and there it is over here. I'm going to go full screen on this over here. So once these projects have been linked on the MCAD and the Ecad side together, then they do ping the server every so often just to see if there's an update. In this case, it did find that here. Close that there. All right, and so I don't want to discard it in this case. This time I want to view the changes. Okay, so let's take a look at what he's done. And of course, we only move one part, but if you moved a bunch of different things, we'd see each one of those as a line item. And of course, if you've got a board that's got a lot of stuff on it, you may just not know where U1 happened to be. So what's nice about this is that when you click on one of these line items here, you can see on the screen over here, there is a kind of a purple shadow that's coming up to show where this is going to be proposed. Okay, so there it is over here. If I missed it, I can always click on another part of this line item here and we can see it. On the 3D side, we can also see it as well. So if I click on U1 here, we can see that this is coming in, and there it is. Now, in my situation, this is not really good. So this is a really great example of why you want to have really good 3D parts when you're talking between Ecad and MCAD, because in this situation, Tom thought that this might have been a flat pack, or that this really didn't have leads that were all that, that were sticking out all that far. So when he moved it over here, he didn't see the pads. Okay, and if he had the gull wings on this, if this was done a little bit more properly, he would have said, "Oh, this is going to be too close. This is going to be problematic." So as a result of this, I can't use this because this is going to cause me a lot of issues. So if I like it, I can click accept, and it will move it. But in this case, I'm not going to accept it here. At least I'm just going to reject it from this level here. But I'm going to accept the fact that he has done this so that at least we have a revision update in the PCB services. So I'm going to click this here. Okay. And now we have a little bit of a situation. The situation is that I've rejected it, and my board looks like it did before initially. Tom's still got a board that's showing that this U1 is adjacent to the switch here. So I need to push back a notification saying I can't have it where it's at. So I'm going to click on push here, and I'm going to say, sorry, U1 is too close to SW1. Okay, and so before I post this here, I'm going to split the screen again so you can kind of see the real-time effect. So we've got the two screens up over here. So when I post this, okay, then you'll see here in just a couple of seconds that the notification will show up on the MCAD side.
Okay, so now I see here in Houston, I see that Paul over in San Diego didn't like what I did. So what I'm going to say is I'm not sure what he is. I'm going to go up like he says and do a view changes. And basically what this change is, it's an unchange. He's basically undoing what I did, but from my point of view, it's still considered a change. So let me get a little bit better view. So the same situation is on the Ecad side. I can click up here on each individual thing that happened, and I will get an animation showing what that occurrence was. And in this case, it's basically undoing what I initially did, but you can see he's moving the chip back. So in this case, I'm going to say, well, he knows what he's doing. I have to accept it. So I will click the accept switch up here, saying, yes, I want to let that happen, and then I'll accept his message. And by doing that, we are now going to synchronize up. The system is talking to the server. I'm getting the actual board that he's got. And at this point, we have both been synchronized again. Since Ecad owns the project, it's up to me to synchronize with him, not vice versa.
And again, this whole process can continually go on. So if Tom still needed me to move it, or if he told me saying, hey, you can, if I went back to him, for example, and said, hey, look, Tom, I see where you want to put this. It's a little too close. If I nudge it over to the right, is that going to be an issue? So I could have accepted his, pushed it over, and then still pushed over the entire project back to him, and then he would still just have to do a quick update. So you can go back and forth pretty much as you need to, and until you finally got this board set up that everybody likes where things are being placed. And again, we can move components, we can add, move, and delete mounting holes, and we can modify the board shape through this type of collaboration over here. So that's an example of an Ecad initiated design being pushed to MCAD and vice versa. What we want to do is just kind of show you a kind of a second scenario that happens quite often, and the tool can assist you in this as well. So let's, so Tom, why don't you bring up your, bring up the other example. So in some cases, what happens is that on the MCAD side, you initiated the design beforehand. So you've already started to draw it out. Maybe marketing came over and said, hey, we need this particular enclosure. We want to see how this is going to work for our marketing purposes. So you've already started the mechanical side of it, and now you got to fit some type of printed circuit board in there. So this is now MCAD kind of driving the shape of the printed circuit board. And so that's what you're seeing on the screen over here. So Tom now has a board that he wants me to use when I'm putting together my printed circuit board. Okay. Now, as we mentioned earlier, unfortunately, we have to start everything from the Ecad side. So just to show you what we've done here, okay, is let's bring this up to full here. On my side over here, I have to initiate a project. That's all I need to do is to say, okay, I have a new project over here. I have a new printed circuit board, and this is the default. I believe this is, I think, 6 by 6 inches over here. And we can change the board size within the Ecad tool, but actually it's a lot easier to get that information from the MCAD tool, especially if they know this is going to fit in their enclosure. So as long as I've got this set up over here, he can initiate the transfer from the MCAD side over to the Ecad side, and that's what we will show over here. So let me bring both screens back so we can see that. Okay, so Tom, go ahead.
Okay, so as Paul mentioned, I need to have his project name set in before I can push, because I need to know where to go. So in the interest of time, we went ahead and did that process. So you can see over here, the project is linked to the new project that Paul created. I've got a relatively simple board, but like Paul mentioned, I could have done something a lot more complex, more shapes, splines, whatever, mounting holes. Basically got a really nice, board set up in SolidWorks. So I'm basically going to say, okay, I just want to push this board over. So as we did before, I get to have a message. And I'm going to say, this is my initial board shape, and I'm going to post it. And as you will see on Paul's project, it should show up mentioning that I've now posted the board.
And there it is. You can see it on my side over here. I'm going to go full screen here. So I'm going to view the changes. So we'll see our line item over here. So here is the board outline. In this case, I will accept it. So I will press, yep. Oh, I should have done the, I'm sorry. One of the things I should have done there earlier is the preview. But nevertheless, let me split the screen so you can see that the shapes are the same here. And you can see that, yes. But I could have previewed it as well if I wanted to see it. But Tom was pretty dead on determining to make sure that I used this board over here, so I accepted it as is in our project example. But there it is, all right? And again, we can start going back and forth. So if I push or add footprints onto my design over here, and I want to show those back to Tom, then I can easily do so. And that's the whole idea, is to be able to push this stuff back and forth. So hopefully you get a good feel for what these tools are capable of doing. And I think the big thing you can realize is that when you're now pushing 3D between SolidWorks Pcb and you're pushing it between SolidWorks Cad, you're getting something not only in real time, but you're getting something that's real, right? It's real intelligent data that you can work with and manipulate in real time now. And that's really the beauty of this whole setup. And with that, what I'd like to do is, if you have any questions at this point, feel free to write those in. And I'd just like to talk to you about 9.connects while you're doing that over here. So, we've been in this business for a long time. When I say business, we're talking about the printed circuit board business. We've sold products, we do services, we do trainings, and that's what our focus is on. We don't sell any other product in the SolidWorks line. Our focus is on SolidWorks Pcb because that's where our field of expertise is. And we really do three different things. We do training, we do the services, and we also do consulting. So what do we mean by that? Well, first and foremost, when it comes to training, we cover a large area. Our flagship training program is something called PCB Fundamentals, because what we understand about printed circuit boards, believe it or not, electrical engineers are not taught how to make printed circuit boards in academia. They're just not taught that. Okay, academia is not caught up with the fact that electrical engineers now have to do the printed circuit boards because they become so complex. They still think that's something that's handed off to a lab technician. So there's a huge discontinuity going on between industry and academia. And so we've kind of taken the bull by the horns and say, look, if you are an engineer, a designer, even if you are a technician, if you're a program manager, even a purchasing agent, if you have anything to do with printed circuit boards, we have a 3-day class that we can show and explain how this whole process works. Because one thing about putting together a printed circuit board, if you don't own the process, it will certainly own you. And I can tell you numerous battle stories and war stories about things that just didn't go right because people really didn't understand the process. And of course, we are experts in SolidWorks Pcb. 3 of us are now certified by SolidWorks as experts in SolidWorks Pcb. And so we also train in that. We can also consult. We also sell the product and support it if you do purchase it from us. There are other trainings that we do as well. We call them stealth trainings because we really don't have manuals for them, but we have this kind of knowledge. And a lot of times when we work with people, it's more about guiding them in something that they're doing. So for example, if they're working in libraries and they want a better component library, they may ask us, well, guide us along. What are we doing right? What are we not doing right here? What can we do to make our library flow work better? Or if you're familiar with SPICE simulation, that's something that we use on the analog side of electronics. And a lot of people want to know how to use it. And so again, we can show people how to make use of the SPICE simulation engine, which is also included in SolidWorks Pcb, by the way. We talk about, there's one-day trainings that we have, and you can just look online to see what those trainings are all about. So we do provide a number of different trainings depending on what you're looking for. Some of them very formal, some of them very informal. We also provide services as well. Okay? So if you're looking for anything in terms of services electrically, come talk to us. We know that, for example, the big buzzwords like artificial intelligence and IoT and mechatronics, these are all great things and everybody wants to get involved in them. However, if you know nothing about the electronics or where to even start, that can be really daunting. So if you're traditionally mechanical and you're looking for assistance, some type of assistance on the electrical side, we can certainly provide that. And by the way, even folks on the electrical side come to us as well, because a lot of times they've been doing something over and over again for many years, and now all of a sudden they've got to get into, let's say, Wi-Fi, or they got to get into something that is high speed, and they're just not very familiar with that type of design. We can certainly assist them with that on any level, quite frankly. We do library component development. There's some companies that say, look, our libraries are a mess. Take what we've got over here and build us a library. We do that. And again, also circuit simulation, depending on what type of simulation you're trying to do with it. And the other thing we also provide is what we call consulting. So normally services and consulting are based on whether there's a hard definition or it's a soft definition. If it's something where you come and say, lay this board out for us, fine, we can do that. That's a hard definition. That's a service. But if you're coming to us saying, like, look, we're putting together a design, and there's an area of this design which requires RF, and we're just not strong in RF, can you review what we're doing? Can you help us out design that? That's when we start getting into this concept of consulting, and we can provide that as well. So a lot of the big things that we have to deal with today is RF, high speed, power, analog. These are areas that are really difficult, quite frankly. And a lot of electrical engineers, just because they have a degree and they may have taken a class or two in this stuff, they're not very strong in it, just because it requires it really requires some industry experience, which is what we have. Okay, things like design for manufacturing. This is a big thing, because a lot of times people create printed circuit boards and they follow the rules, but if they didn't set the rules up right, they get it into the fabricator, to the assembler, and they'll say, look, we really can't manufacture this for you. It looks great on paper, but we just cannot turn this into reality. And also library methodology as well. When there's 150 million electrical components out there, and remember I talked about having 2 different libraries, libraries really become a very complex creature on the electrical side. So that's who we are here at 9.Connects, and hopefully you guys have written a couple questions in there, so we're going to take a look at those here